Most RL tutorials out there use either mountain car, kart pole or lunar lander as their environment and assume an understanding of gym. So, let's use this video to get familiar with gym. Hi there you beautiful being, how are you today? I'm Sasha Nair and welcome to this channel. Today, we'll be going over what is gym and why it exists and how to use it for our implementations. Reinforcement learning presupposes the existence of an environment. It is built on the premise that an agent learns through its interactions with its environment. And that is where OpenAI Gym fits in. If you need a quick refresher on the basic working of reinforcement learning, click on the video linked above. OpenAI Gym was born out of a need for benchmarks in the growing field of reinforcement learning. It thus provides a diverse range of environments or tasks to test out your RL agents. It makes no assumptions about how the agent is structured and instead focuses on providing abstractions for the agent to interact with the environment while prioritizing ease of use and accessibility. With that out of the way, time for more fun things. Let's look at how to use Gym for your implementations. And let's switch into the console view. Let's start with this newly created Conda environment. As you can see, Gym is not available in the environment. To install, we simply use pip install Gym. Let's test our installation. Environments in the algorithmic and toy text categories work right off the bat. But if you wish to use a Box2D environment or an Atari environment, you'll run into issues. To fix this, you need to perform an extra pip install step and install the corresponding environment category. Let's test this once again. And there, we have it working now. Time to switch into Sublime to get an idea of the code. We already saw gym.make while testing our installations, which is used to create the environment. Every environment must be initialized before the agent can start interacting with it, for which env.reset is used, which returns the initial state of the environment. For the agent to perform an action, we use env.step and pass the desired action as an argument. However, since we don't have an agent, let's test by sampling a random action. The step function returns the new state of the environment that has resulted from the agent performing the action, reward that will help guide the agent's learning, done, which is a boolean indicating if the terminal state is reached or not, and info, which is usually empty. Let's examine what happens when we run this. Going back to the code, we had ignored action space earlier. Action space specifies the range of actions available to the agent. Similarly, there is observation space that specifies the type and range of the observations available to the agent in the state variable. For example, in the kart pole environment, 2 discrete actions are allowed, and the observation space is a continuous array of size 4 as indicated by box 4. Alright, so till now we saw how to create and interact with the environment, but we performed only one step. While in reinforcement learning, we need to perform millions of steps of interaction. So let's modify the previous code such that it works in a loop that iterates over game episodes. This means that as soon as a terminal state is reached, as indicated by the done flag, the game is reset and a new episode begins. Fingers crossed that it works. And yay, there it is. This is great and all, except that it is just all text. With RL, it can help to see how the agent is interacting with the environment. So let's modify the code. For this, we just need to add env.render within the while loop. Also, don't forget to add env.close, otherwise it might throw errors. This is perfect now. You can run your agent with any gym environment. Let's recap. In this video, we saw that Gym is a toolkit that makes it extremely convenient for you to start testing your RL algorithms. Using any of the available environments is just a matter of plugging the name of the desired environment into the argument for the gym.make function. It thus allows developers and researchers to focus on the learning algorithm instead of worrying about the structure and the working of the environment. So that's all for today's video. Hope you found this helpful. And thank you for stopping by. In the next video, we'll look at how to use custom environments with Gym. So I hope to see you in the next one. Ciao!